Hi, today in class we started studying inequalities. It's actually lesson 5 in our unit 4 on different kinds of linear equations. And you know that an inequality consists of these different types of symbols. This one, which means less than. This one, which means less than or equal to. This one, which means greater than. And the last one that's also an inequality is this one, which means greater than or equal to. So those will be the symbols that we'll be using in things for the next few days instead of an equal sign. What we did before were equations, and one thing equaled another. In this case, these are inequalities. In, the prefix in, as you know from English, means, it's right, not. So these are not necessarily equal. So we went through the activity today in class where we talked about what preserving the inequality symbol meant. That meant that it stays the same, and that reversing the inequality symbol means that it switches. And so you were to understand that concept today from the activity we did in class with the dice. So you rotated to these different groups, you filled in these different charts. I gave you some hints on the side as to what exactly should go in those blanks or what exactly you should write at the bottom. We had a discussion, and then you were to complete your student exercise. Hopefully you got that done in class. If not, let's take a look at a completed one really quick. The difficult part about this is you all could choose something different. So this is just an example that you can look at to see if you were close or to see if you were on the right track. So the inequality is 2 less than 5. If you add 4 to both sides, you get 6 is less than 9. That's true. Now you're to find an operation in a new equality which reverses the symbol, which means you would need to multiply or divide by a negative number. In this case, if we take 2 times negative 4, we get negative 8. And if we take 2 times negative 4 times 5, we get negative 20. And so in that case, the symbol would have to be reversed. And then you need to make sure that you've got a good explanation. Adding a number to both sides of an inequality preserves the symbol using that vocabulary that we used in class. Multiplying by a negative number to both sides of the inequality reverses the symbol. So you're to do the same thing all the way down. You come up with the operation like subtracting something from both sides, and that would preserve your symbol. Or you could divide both sides by a negative number, and that would reverse your symbol. So again, we go through that explanation of subtracting a number to both sides. Uh-oh. Is this running? Yeah, okay. That's your secret. I got lost. I couldn't tell if I was running or not. Subtracting a number to both sides of an inequality preserves the inequality. Dividing a negative number to both sides of an inequality reverses the inequality. What is going on here? I am moving the wrong things. Okay, so Ms. Trouzo goofed again. There is your secret. Whoops, whoops, and goof. Again, with the less than or equal to symbol, in order to reverse the symbol, you would have to either multiply or divide by a negative number to reverse the symbol. And then for the last one, you would have to add or subtract to preserve it, multiply or divide to preserve it. So that gives you just an example. You shouldn't have this exact one, but it should help you decide whether what you did was correct or not. What you were actually to do tonight was your problem set. So let's take a look at that. So the box here is a summary of what we did in class. When both sides of an inequality are added or subtracted by a number, the inequality stays the same, and the inequality symbol is said to be, oh, I lost my, golly, goofed again. There's your secret. So the inequality is said to be preserved. When both sides of an inequality are multiplied or divided by a positive number, the inequality stays the same, and the inequality symbol is said to be preserved. When both sides of an inequality are multiplied or divided by a negative number, The inequality symbol switches from less than to greater than, or from greater than to less than, and the inequality symbol is reversed. So these were the concepts that you were to learn, and now we are to practice. So for number 1, it says for each problem, use the properties of inequalities to write a true inequality statement. The two integers are -2 and -5. The only true inequality statement that could be written is that -5 is less than -2. Now, if that confuses you, you have to remember that -5 is further to the left down the number line than -2, which makes it smaller. It has a larger absolute value, but its position is to the left on the number line, and that's what makes it less than. For number 2, subtract -2 from each side of the inequality. Write a true inequality statement. Okay, so let's see how that goes. If I've got -5 is less than -2, and I subtract -2 from each side, I've got -7 is less than -4. Is that still true? I believe that it is, because -7 is further down the number line than -4. Part C. Now you are to multiply each number by -3. So we go back to that original. -5 is less than -2. We want to multiply each side by -3. -3 times -5 is 15, is less than -2 times 6. Well, that's not true. So this would be one of those situations where your symbol would have to be reversed, because you multiplied by a negative on both sides. So you reverse the symbol. It's no longer preserved. Whoa. Number 2. What time is it? Okay, 7. On a recent vacation to the Caribbean, Kay and Tony wanted to explore the ocean elements. One day they went on in a submarine 150 feet below sea level. The second day they went scuba diving 75 feet below sea level. Write an inequality comparing the submarine's elevation and scuba diving elevations. So one day was 50 feet below sea level, and the second day it was 75 feet below sea level. And you need to write a correct inequality for that, which would be that -150 is less than -75. I would also say you could do -75 is greater than -150. I would think either one of those would be possible options. Now, if you are only able to go 1/5 of the capable elevations, write a new inequality to show the elevations that they achieved. So now we got to figure out, how do you find 1/5? There are two ways to find 1/5. You can multiply 1/5 by 1/5, which I'm sure all of you are eager to do, but you could do it on your calculator, or you can divide both by 5. So if we took -75 and divided it by 5, we should get one side, and -150 and divide it by 5, we should get the other side. So we end up with -15 and -30. Well, if I'm using this way, -15 is greater than -30. If you did it the same way in A, your -30 is on this side and your -15 is on this side, and it preserved the symbol. So was the inequality symbol preserved or reversed? It was preserved, because the number that was multiplied to both sides was not negative. All right, on to number 3. Whoa. This is what happens to me when I try something new. I have technological difficulties. Difficulties. I'm trying to find number 3. Really, I am. And I'm trying to get it up high enough here. What? on the screen so you can see it. All right. So for A, it says if A is a negative integer, then which of the number sentences below is true? If the number sentence is not true, give a reason. So your first choice there was A. Well, I got A and B. I can't not do both of them. But if this was a negative number, -1 or -2, would the answer on the left be less than the answer on the right? If this was a negative number, 1 or -3, would this be true? And what you can see is A is true, but B is not, because adding a negative number to 5 will decrease the 5, which will not be greater than 5. And I want you to see these good explanations, because that's one thing we really need to work on, are explanations. All right, let's try another one. Well, crap. All right, here's C and D. If you were to subtract a negative, and it could be 1, and you can do this on your calculator to test it, or you can remember that subtracting is to add the opposite, so we're really adding 1. 5 minus a negative number is going to be greater than 5. 5 minus a negative number is not going to be less than 5. So C is true and D is false, because when you subtract a negative number, it's really like adding a number to 5 because of that whole idea of add the opposite. So that's going to make something that is larger. E and F. E is true. Hold on. What have I done? Come back here. E is true because if you take 5 times -1, you get -5, and that is less than 5. If you take 5 times -1, you get -5, and that's not greater than 5. It's false because a negative number multiplied by a positive number is negative, and that's going to be less than 5. Let's see if I can do this in the right order. Erase first, Miss Trousdale, then scroll down to the next one. Aha, look at that. It's amazing how it works. Okay, for number 5, letter G, if you add a 1, 5 plus -1 is going to be 4. 4 would be less than whatever that negative number is. So this is going to be true. It doesn't matter what you substitute in there. It could be -1,000,000. It's still going to come out correct. But if we do -1 over here, I get 4 is less than -1. That's false, because when you add a 5 to a negative number, it's still greater than that negative number itself. Okay, erase. See, I'm getting this in the right order now that we're getting down to the end of it. Scroll. Too far. Now, if you haven't already tried these, goodness knows I can't hold it still long enough for you to copy anything, that's for sure. Please try them before you move on. If we look at the next one, we can't because it's gone. If you subtract a negative number, I'm going to use like negative, I don't know, 3. It's the same as adding the opposite, 5 plus 3. So 8 would be greater than my negative number, the -3. 5 minus a -3 is 5 plus 3, so this is 8, would not be less than -3. So again, this one is false, because subtracting a negative number is the same as adding that number, and that's going to make it greater than the negative number. Erase. Scroll. And we're down to the last 2, right? I believe so. 5 times -5 is -25. So -25 would not be greater than -5. This one's false, because a negative number multiplied by 5 is a negative and will be 5 times smaller than A. For L, 5 times whatever negative number you want to try, again, I'm going to do -5s, -25 would be less than 5, and that one's true. All right, we will move on